So who here, can I have a show of hands, who here has ever thought about how robotics and AI will work together with you, with our people? In my case, looking at how we can inspect stuff. Is anyone already thinking about this or some ideas about how this is happening? Yeah. Well, we at Vestot, we try to bring that future forward by also investing in robotics and in new technologies. One of which also to see how we can use the Metaverse and how we can use virtual reality, augmented reality in our jobs, actually. So I'm Martijn Kuits, I'm Innovation Manager at Vestot. We're part of the Kiva Group, so I work closely together with Thomas, with Kiva here in Finland. And I'll give you some ideas about how we're using it, what we're working on, mainly robotics at the moment. So I'll bring you to it. So if I can set the scene, what we see today is that inspections, we see that inspections are actually very high risk. So people need to crawl into very tight spaces, confined spaces, working at heights. It's creating a lot of accidents. There are also a lot of costs because if you have to send people to dangerous places, there's a lot of preparation needed. And actually the budget that is needed for the preparation exceeds the budget that is needed for inspection. So the entire budget of the inspection maintenance can be quite big. I will show you some cases of it. And then in the end, what we'll see is that we have limited insights. Usually a report is like a PDF. It's good, it's not good. Now what? So it's not really something that is good for the time that we're in. And to make things worse, we see that the world is a bit changing. All our infrastructure here in the West, it's been post-war, so more than 50 years old. It's crumbling. So it needs more inspections. Unfortunately, the highly qualified inspections, we have less of them. There are less people who are entering the job, and there is more job to be done. And as a double whammy, there's economic pressure to reduce the shutdown as much as possible. Luckily, there are some technological advancements. So we have AI that can help. We've got robotics connected, 5G, so we can work we can work via the cloud. There are digital twins. The challenge is these create a lot of data. It's very tough to make them interoperable, to use them effectively together, and then also how in this technology and or people leaving, or older people, how do we actually exchange the knowledge between those groups? And then also there's legislation that is standards that are changing, adding on to the complexity. In Vestot, we are starting a project called Intelligent Inspection, where we want to use these technologies to go from a reactive stance or maintenance to a proactive, where we want to try to predict how we need to maintain those assets or the customer, and how we can leverage all those technologies in the jobs that we do. So if you look at the opportunities in intelligent inspection, this is how we do inspections today. We do have some robots, we do have some drones and an operator, but what comes out of it is just a PDF report oftentimes. It's not really telling. We are changing the way that we are reporting on those inspections. So this is a tool that was made in Vestot. It is made by Kiva in Sweden. This is with a robot manufacturer where you can see all the entire details. At the same time, we're looking into how can we bring augmented reality, for example, to reporting, but it can also be interesting for the inspection. So the inspectors, so they see the last inspection that was happening, so they have a better understanding of what's going on. And we try to do automation as well with robotics and drones. What we finally want to come at is that we actually want to use also AI and digital workflow and data analysis to come to a better understanding of the assets that that the customer has. What is the optimal maintenance time to do risk-based inspections instead of time-based? And this for us as a company obviously leads to better insights, which we can then also commercialize and create new services and value streams. So that's the job that we have. There's a particular job for robotics because they fill in the 6 Ds, so the dull, the dangerous, the dirty, the demanding, and distributed and distant work. Distributed is like wind turbines, for example. Distant can be offshore platforms, for example. And what we see is that with these remote inspection technologies, we reduce a lot of the risks associated with the inspection because the inspector is not close to the danger. It also has a big impact on all the preparation and the production stuff. So we usually have smaller teams, no scaffolding, a lot less admin required, and thus less impact on the cost. And at the same time, we can increase the inspection speed. We can also have a better coverage, better data quality because the consistency of the data is improved, and with that consistency also comes the actual insights, and also we can automate. So to some extent get the human out of the loop for data capture as well. So how is robotics changing the game? These are some projects we're working on. One of the topics we're working on now very heavily in robotics is corrosion under insulation because it's a big problem. I'm going to very briefly show you why. But the big project now we're working on is to do corrosion under insulation inspection on these pipes. So these pipes are insulated. When moisture gets into the pipe, then they start rusting. Usually they have some very corrosive and very dangerous liquids or gases moving in them. So it's really crucial to inspect. There are a few assets that are affected, like storage tanks, heat exchangers, but mainly piping that's affected. And you can see the impact of that corrosion depending on how well these pipes are prepared. The cost associated with COI inspection on piping are enormous. We're talking for mid to large range or size facility, we're talking between 1.5 to 5, 6 million euro per year. Because you need to strip these things, then you need to take a measurement, build a scaffold, and then again apply the entire cladding and so on. And it's very risky, obviously, because if there's still liquid inside and you're removing the cladding, you might rupture the tube, and no one wants that, obviously. So it's very costly, which is why it's a focus for us now to work on solutions. One of those solutions is what we call Robotic project. So what we want to do is to add this robot arm. It's 5 meters. It can go vertical. It can go 7.5 horizontal, and we want to add some radiography tools on top of it. So if we use X-ray, it's a smaller intensity. You get something like this, or at least you can actually scan right through the tube without removing the cladding, and it will give you some information whether there's corrosion or whether there's some issues going on. You can see it here as well. And this will give us some idea that something is missing or going wrong inside these tubes. If we really want to do measurements, we will have to use gamma radiation, so really it's a particle that we need to bring there and then shoot it. And then you can take actual measurements, the thickness. And the thickness is what you can then use to do calculations, what is actually the rate of damage and when will it probably fail, to do some predictions. The good thing is we don't need any scaffolding anymore. We can bring it on an aerial platform and then bring the robot in position to do the inspection, and our people are at a safe distance. Another project is a universal crawler. So we recently got this one. I think we were one of the first 10 people who are now testing it. And it's a crawler that actually sticks to any surface, which is very nice. We have to have crawlers, magnetic wheel, we've got suction-based crawlers, but the problem with suction-based that actually when there's a little bit of a rough surface, they don't work anymore. This one does, and you can even see here on a corrugated plate, it's not even magnetic material, it can even crawl upside down. What we want to do now is integrate sensors on top of it, and one of the sensors is a back probe. It's called steady current, and it can actually also look underneath the cladding of tanks that are insulated. Again, no scaffolding, safer operation, and a much quicker inspection method. We can also use that same robot then to also inspect concrete. So you've seen the picture before, the vision of where we have also the same concrete silos. And we do a visual inspection with AI looking at the defects. Once you have found a group of defects and you want to go deeper into the concrete, we can use this robot and then some tools from screening eagle prosec that can actually look through the concrete. So there are some tools that use also eddy current related or UT or ground penetrating radar, and we can see what's actually going on inside the concrete. So it gives us a full view of what's going on with that asset, and then again help the inspector or help the customer.
Is there a tool or robot you can use on ferrous environment or surface? Is this for non-ferrous? So
if it works on non-ferrous, it will work on ferrous as well. Yeah. Okay. But we have crawlers specifically for ferrous material. The challenge was, what do we do now with stainless steel tanks or with tanks that are insulated? Which is why this robot was really interesting. But this works on every surface.
Okay.
It works on very rough surfaces. It can even traverse a critical ledge of a couple centimeters. We've been testing it. Yeah. But ferrous, non-ferrous, anything. Yeah. As long as it's not too complex, then we need something like this. If we look at the future, what we want to go towards is also start using VR in those inspections, especially for very complex inspections. This robot that you've seen, the float arm, it actually already has a continuous simulation of itself within a virtual environment. If we can then add that environment into something like we see here, like you see a full digital twin of the site, we can prepare for missions. We can be more efficient on site. Again, reducing the downtime, but also working safer. But we can also train our people without having the robot. So we can start training people on the Xbox controller because that's how we operate it. So there's a lot of benefit here. A lot of prototyping we can do, and you can even do a full remote operation. So we could have people in Japan inspecting an asset here in Europe. Also, it's aware of itself, but you see that it also takes point clouds when it's operating. That means that it's actually aware of itself all the time of the body relative to all the points in the point cloud that it is taken. And this would help us to avoid collisions because the robot is aware of it. It also means that we can click on any point in that map, in that point cloud, and the robot will go there automatically. So it will define a path. It will find a way for its body to move around obstacles and then take the measurement. And again, which is very interesting, we actually got a very good coordinate of the measurement relative to the object, which is very important when we want to do reporting because you can see where the measurement was taken. And again, you can of course do the motion planning in advance. Then what we also need to do is bring that data over to a solution cloud-based. There are a few reasons for this, but the biggest reason for us is, like I mentioned, we've got very few qualified people. So when we have a level 2 or level 3 NDT person, it takes years to train him. And when you send him on one mission, he can only do one mission. He's a very valuable person. We want to have those profiles in a central hub. And they can actually access live the data from NDT, from visuals, to help with more junior profiles. It also means that more junior profiles will more quickly gain their qualifications because they're the ones steering. But it also means that of course, the end customer has got all the results, all the inspection data at his disposition. He's got a really comprehensive view because the data points, like I said, are related to the point cloud. So he knows exactly where a measurement was taken, and we know each time we do an inspection, it's the exact same point we take. So we can do a really good trend analysis on those data. And then, of course, we want to use more software tools. We want to use tools in the field like AI, edge computing, to help those junior profiles, at least to tell them, look, here is something you need to be aware of, or to tell them your measurement is rubbish. I cannot really make sense of it in the future. Please take a new measurement, especially when you do thickness measurement, erosion mapping. You want to make sure that the measurements you take at the time are correct so you don't have to revisit the site, obviously. And then we want to use that data to calculate remaining life, to do predictive maintenance, to calculate the corrosion rates and so on, and then offer the customer actually a new way of inspecting, which is a risk-based inspection where we can say, look, these parts of this asset need to be inspected at a different interval then maybe some other portions of your asset instead of every X years, the entire thing. So that was my presentation. It was a lot of slides, but I think I made it in time.
Excellent.
If there are any questions, please let me know.
Of course there are questions.
Yes.
Yeah, I mean, you are doing inspections for sure, but when doing this testing and developing, have you kind of thought that maybe this would be a very good way also to repair something or build something?
Yes. We are looking into cleaning something, because one of the big problems we have with inspections is that when it's corroded, you cannot do a new thickness measurement. It will not work. So we're looking for cleaning options. The robot that we have seen is also, they're now investing into a coating option to prepare some surfaces. The thing for us is that we don't know coating or these repair stuff good enough. So the only way I think forward for us is to partner up with someone who does, because it's not our job. There's too many risks for us to give you guarantees as an end customer on that job. Yeah, that's a problem. But it's possible. It's how we want to indeed find partners who can do that, so we can give the end customer the full package together. We completely take it out of your hands. We make sure it's clean. We've got inspection zones, and we make your asset as new for you.
Yeah, hi, Kenneth Florano. My question is whether there's any regulatory restrictions if you're trying to validate like a specific component that you're inspecting, virtual versus physical.
There are a lot of standards, obviously, that we need to use that tell us how to use the techniques, and we need to do a technical justification of how we operate. That's part of it, so that's the media API and so on. We need to follow those. That's what customers demand. There are some laws as well in Belgium, especially for pressure equipment, which we need to take into account. But there we see that the legislation is lagging on technology. So a lot of it is actually still prescribes visual inspection, and when you do a tank, you need to do like 3 measurements per ring. Which to me sounds like a very bad idea, because where you have the fluid meeting the air, for example, you have corrosion, and you will easily miss it in those legal inspection descriptions, which is why we go a step further with the industrial services that we offer, the NDT. We go further. It's where you want to see actually the state of your asset. We go to the extra legal activities. And then it's important to follow the safety concerns and the justifications that particular companies have in place to get approvals for that particular site. Yeah.
How big it is. I was surprised. I didn't see any drone in your slides.
Any?
Flying drones.
We have, but flying drones, for me, it's like the first job. It's a technology we used to do first screening, and then when we have screened, we found some troublesome areas. We need to go in and take a measurement. So drones are a qualitative technique. It will give you an idea of the issue, but you cannot make any calculations from it. So we are now actually finalizing an investment in a company that will take care of that part. So they will be responsible for drone activities. The way that I compared it is that the drone company or the drone is more like a general practitioner. And when we see a problem, we need to go to a specialist, and that's what we're showing. But we have that in the portfolio. Anyone else? Yeah.
Have you thought of inspecting buildings?
Yes.
Okay.
Yes.
Structures and road things.
Yes, we have. So the crawling robot is one of those where we can see indeed for at least for bridges and so on to have. Pictures are not here, but we have some use cases when we start exploring. For building, we were also looking into the NEM 2767 norm, which is a norm that is for condition monitoring of buildings. where we also want to use drones to do the visual inspection, and where we can then also use AI to actually already make give an idea of the areas and to give an idea of the degree of defect. So, yeah, definitely. And then again, it's a combination of drones and a robot working for the only thing we cannot remotely do is drilling. So actually, for samples.
Any ideas for fire safety?
Yes, actually, it's an interesting question. We're just in the process of patenting a solution we have. So we have a solution where we put a canister on a drone for the smoke detector inspections we do. And for fire safety, we're also expanding whether we can use drones or whether we can use camera systems to increase the visibility of what's going on. So it's a work in progress. It's mainly for big holes or where you have obstacles, where now you need to use an aerial platform, which is very intrusive in the production process. Here we have a commercial drone that has all the safety features, and we developed actually the payload that goes on top. We've got a small button and it releases the smoke, and then we see if it works. So where we
Kind of
find
testing there.
Yeah.
Testing there.
no, we're commercializing. It's working.
Okay.
So it's a smoke tester we have. You can have all the systems. If we have an optical system or a laser beam system, then we use a filter basically to disrupt. So all right. Should you still have questions, I'm still here. So can you grab a coffee, please? Thank you.